In this problem, we're going to be working with the rational function 15x minus 12 over 3x plus 4. And we're going to find the domain and the vertical asymptote, etc. And so I went ahead and started out by graphing the function on my graphing calculator. So what I did was I went to y1 and I went ahead and put in for y1 the following. Parentheses 15x minus 12 divided by, and then I press divided by on my calculator, 3x plus 4. And that's going to help the calculator understand what the full numerator is and what the full denominator is. And then I graphed it on a standard window, which was zoom 6, and I got the shape that's shown in the window here. And it looks a little odd because it's in two pieces, but these rational functions do that. Sometimes they're in more than two pieces, but this is very normal. This entire image is for the window is the graph of the function here. So let's start with the domain, and to find the domain for this function, what I need to do is to figure out where the denominator, 3x plus 4, equals 0. I'm going to solve for x, so 3x equals negative 4, x equals negative 4/3, which is approximately equal to negative 1.33. That means my domain is all real numbers x not equal to negative 1.33. Give the equation of the vertical asymptote, which I get for free from the domain. The equation of the vertical asymptote is the vertical line that passes through the value for x we found in part A that's eliminated from the domain. So if I go to my graph and I look at negative 1.33, which is about right here, I can draw a vertical line that goes through that, and that's going to be my vertical asymptote. Give the equation of the horizontal asymptote. So the horizontal asymptote is going to be the guiding line for the outputs of the function. And so what I'm looking for is as x approaches, we can use that arrow, plus or minus infinity, what does g of x approach? Well, g of x is going to approach the ratio of the highest degree term in the numerator, which is 15x, divided by the highest degree term in the denominator, which is 3x, because as x values get really, really big, these numbers, negative 12 and 4, are not going to impact our result. It's only the numbers that are the highest degree, or attached to the highest degree terms. So 15x over 3x reduces to 5. So g of x equals 5 is the horizontal asymptote. And I can put that on my graph here. 1, 2, 3, 4, 5. I can draw that horizontal line there, and you can see that the outputs are going to guide along that line as x gets positive infinity and negative infinity directions. Part D, what is the vertical intercept? For that, I need to evaluate g of 0, meaning replace x with 0. So 15 times 0 is 0. So 0 minus 12 over 3 times 0 is 0 plus 4 is negative 12 over 4, which is negative 3. So that gives me 0, negative 3. And let's put that on the graph. 1, 2, 3. Looks like it's about right there. I'm going to label that 0, negative 3. What is the horizontal intercept? So to find the horizontal intercept, I want to know what input gives me an output of 0. 15x minus 12 over 3x plus 4 equals 0. So I want to solve this equation. So for vertical intercept, the input is 0. For horizontal intercept, the output is 0. So I'm trying to fulfill the ordered pair something, comma, 0 here. And with this one, it was 0 first and then the output. So solving this equation, I can multiply both sides of the equation by 3x plus 4. If I do that on the left-hand side, the 3x plus 4 in the denominator is eliminated. If I do that on the right-hand side, I just get 0 as a result. So 15x minus 12 equals 0. Solving for x, 15x equals 12. Moving over here, x equals 12 divided by 15, which is 0.8. So my horizontal intercept is 0.8, 0. For part F, determine g of 12. So I'm going to replace my input value with 12. 15 times 12 minus 12 over 3 times 12 plus 4 equals 180 minus 12 over 36 plus 4 is 40. That gives me 168 over 40, which equals 4.2. So I have the ordered pair, 12, 4.2. I can't graph that in my window here because it's outside the window, but if I go over here to 12 and up, it looks like it's going to be right in line with what my graph is showing. And same thing here, I didn't look at the horizontal intercept, 0.80. So if this is 1, the graph's going to cross about right here, which is 0.80. Good to put that on the graph. Okay. Part G, for what value of x is g of x equal to 3? And what we're doing then, 3 is output. So I'm going to set my function, 15x minus 12 over 3x plus 4 equal to 3. Multiply both sides by 3x plus 4. That's going to clear the fraction on the right-hand side. On the left-hand side, I get 9x plus 12 equals 15x minus 12. I'm going to subtract 9 from this side, add 12, actually subtract 9x from both sides, moving the 9x over here, making it negative. Negative 12, I'm going to add 12 to both sides. So I end up with 24 equals 6x. Divide both sides by 6. I get 4 equals x. Gives me an ordered pair of 4, 3. And if I go to my graph, 1, 2, 3, 4, 1, 2, 3, there's the ordered pair, 4,